Welcome to the College Guide and welcome to the first installment in Major Discussions, our series where I will be interviewing guests who have come from all different backgrounds, went to different schools, had different majors to get their experience so you can hear from the horse's mouth exactly what is going on with different majors, why they chose them, why they liked them, and maybe even any regrets they might have about choosing their major. Today we have a very special guest. His name is Skyler. He's a chemical engineer who graduated in April 2020, and he's very excited to share everything he knows about chemical engineering with you. But no one knows him better than himself, so I'm going to let him introduce himself. Thanks for coming on the show. Can you introduce yourself and tell us a little bit about yourself? Yeah, sure, definitely. Thank you for inviting me on the show. Like you said, I'm Skyler Cornaby. So I grew up in Mustang, Oklahoma, a suburb of Oklahoma City. We moved there when I was really young. And that actually kind of factored into my decision to go into chemical engineering because chemical engineering, natural gas and energy is a big deal in Oklahoma. So I knew there would be jobs there. And it was kind of what I saw a lot of growing up. I graduated in April of 2020 in chemical engineering. I attended Brigham Young University as well as University of Oklahoma for my first year of school. While I was in school, I had a lot of great opportunities. I was on a research team for a semester or two where I was helping out a professor who was doing research into 3D printing of tissue. And so that was pretty cool. Human organ tissue, I guess I should clarify that. I also played with the BYU men's ultimate frisbee team, which was a ton of fun. I was only on the B team because their A team is crazy intense, and I was a little more focused on school than that. And also, I'm not an athletic specimen. I'm just your average Joe. But I did get to travel all over the Mountain West. We went to Arizona for tournaments, Idaho, Montana, and things like that. Colorado, went to Fort Collins a couple times. So ton of fun, great guys, and kind of a passion I stumbled across while I was in college. Other than that, now that I'm graduated, I work in the aerospace industry now. I worked a little bit in refining and chemicals during school, and I'm looking forward to telling you guys about those experiences as well. But yeah, thanks again for having me on the show. Awesome. Well, thanks for introducing yourself, and I'm really excited about all the things you just talked about. But let's go back to the basics and let's talk about what exactly is chemical engineering for the layman. For our audience here are mostly college freshmen, high school seniors, people who aren't that familiar. How would you explain it to them? Yeah, definitely. So how I always explain chemical engineering to people is I say that chemists are focused on small scale and figuring out new chemistry. We'll say new compounds, especially if you look at like pharmaceuticals. They're always trying to find new compounds that have better effects or are safer. A chemical engineer's job is to take what they figure out and scale it up so that it's larger, faster, more energy efficient, more environmentally friendly, and safer. So in the end, chemical engineers are a little more focused on the how than the why, which is something I like about it. And it's all about, empirical data on large scale processes. And that's something I really loved when I was looking for jobs. I wanted to work in a big manufacturing facility because it just felt so cool to be around those kinds of processes, that kind of equipment, and realize kind of how much stuff you're making and supplying to people in the world. Awesome. Thank you for sharing. Can you tell us a little bit, just a quick summary? We'll get into this more later, but what was school like for chemical engineering? What kind of classes did you take? What kind of projects did you work on? And maybe why you chose chemical engineering in school? Yeah, of course. So chemical engineers take a pretty broad variety of science classes and math classes. As prereqs, before you even start taking your chemical engineering courses, you have to take 3 or 4 calculus classes. You have to take 4 or 5 chemistry courses with labs. You have to take physics. And those are all prerequisites to most of your chemical engineering courses. Once you hit junior year and you're really taking a lot of chemical engineering courses, they typically focus on one facet of chemical engineering. For example, thermodynamics, heat transfer, separations, chemical reactions, things like that. And you take a deep dive into that for the semester. Along the way, you do learn and apply things like statistics, technical writing, presentation skills, and some of those soft skills like that. But the focus is on the scientific, technical type of stuff. At my school, we didn't have to do a capstone project or a thesis. in the same way other students did. We had a senior design project. And part of that is because chemical engineering is always or typically in a really big facilities. And so we couldn't go out and build a chemical plant for our senior project, but there were a lot of simulation techniques, cost estimating techniques, and things like that we were able to use. So for my senior project, I was in a group with 3 of my friends. We did get to choose, which was really great. And we designed a process from a list, and we decided that we were going to do the acetone plants. We designed a facility that could produce 50,000 tons per year of acetone. So that's what, 100 billion pounds of acetone? I don't know. Large scale facility. And along with that, we had to cost out and size every single pump, blower, reactor, storage tank, heat exchanger, whatever it might be, all the equipment. And then we had to prove why we thought it was an economically viable process, that we would actually make money if we did this. And so we had to look at how much do products or reactants, do ingredients cost, how much could we sell a product for, what purity do we want to sell it at. So a lot of factors, both scientific and economic, came into play with this. As far as why I chose chemical engineering, like I talked about, it was a little bit because of what I saw at home, but also it was because I liked science and math in high school. My favorite class was chemistry. I had a really great chemistry teacher. I also knew that not everybody is good at math or science, and so I wanted to take it that way, so to use the skills I have. And as well, I did a couple things that helped me feel like I would enjoy the engineering design process. I was on a robotics team in high school. I also would do home projects with my dad. And so both of those kind of helped me see I like working with physical systems. I like doing design work and coming out with something at the end of the day that works or does something or is functional. As well, I knew I wasn't interested or good at getting into the nitty gritty of things. That's why I didn't go into chemistry, because I didn't want to deal with things on a small scale. You have to be able to understand it to be a good chemical engineer, but in the end, once you get big enough and you're talking about some of these plants that produce 50,000 tons of acetone, if you're within 5 or 10% on your estimate, that's not too bad. And so those kind of wiggle room, if you can do back of the napkin calculations, rough calculations, and get close, I enjoyed that kind of thinking. What order of magnitude or scale are we on? So I kind of liked that. And as well, as a kid, I thought I was going to go work for NASA or something in the space industry, which I do now. But I also have enjoyed working in other industries. I thought about biomedical for a while. That's why I was in that research lab. So a lot of different opportunities and directions to go as a chemical engineer. And that variety is kind of a nice perk of it as well. If any of you are thinking about chemical engineering, where you go to school probably doesn't particularly matter. I went to a couple schools and they had good engineering schools, but chemical engineering wasn't their forte, we'll say. And it hasn't really affected my career all that much, for the better or for the worse. Good companies came to the career fair at my schools, and so that helped me network with them. But in the end, going to a small school as a chemical engineer isn't going to affect your ability to get a job. It might just affect if you want to go work for NASA or Tesla or ExxonMobil, some big name company. It might pay to do some work into what research they do and what companies the schools connect with, so that you have those relationships in place already. Awesome, thanks. That's a great overview. Let's dive a little bit more into what school was like for you as a chemical engineer. Like I said, a lot of our audience is probably students. So right now, right here, they're worried about how hard is school going to be, what kinds of work and projects you had to do, what your tests were like, things like that. If you can explain all that a little more in depth here, I bet they'd appreciate that. Yeah, I could definitely do that. So, not gonna lie, not gonna sugarcoat it. Chemical engineering was pretty hard in college. College is hard for most any major, though. Just trying to be upfront about it. But for me, the way I did it was that I treated it like a job, and so I took enough classes to keep me busy. I was typically in 15 plus credits, which is an average to heavy load. Oftentimes, I was in 3 or 4 engineering courses and then 1 elective, 1 general class. Excuse me. And I was lucky because I have quite a few AP credits from high school that transferred in, so that helped reduce my load a little bit. I know a lot of people, if you came in with no college credit, you were probably going to be having to do 17 to 18 credits every semester if you want to graduate in 4 years. and that's extremely grueling. And so it was also pretty common for people to take 5 years to do this. That way they could take 1 or 2 less engineering courses per semester, maybe in 2 engineering courses per semester instead of 3 or 4, spread your generals out a little more, and really have time to learn and absorb the concepts. So that was common, and nothing wrong with it. A lot of majors are moving towards a 5-year plan anyways. As far as how I studied, I kind of treated it like a full-time job, like I said. So I got to campus every day at 8 a.m. I would ride the bus from my apartment complex to campus at 7:40. And oftentimes this was because I had an 8 a.m. class. As far as scheduling classes, they were usually only offered in one time slot for chemical engineers. They had one thermodynamics class, one heat transfer class, one separations class. So you just had to take it when it was. And oftentimes that meant an 8 a.m. class. But that's okay. I would get to campus at 8 a.m. and I would leave at about 6 p.m. Some days later, some days a little earlier, but usually 6 p.m. So that's a 10-hour day on campus. And that entire 10 hours, I was with my study group or in class. Much to the chagrin of my wife, when we were dating, she would have to come and join the study group. But sure, we became really close friends because of it. The people I studied with are some of my best friends from college. And that's because we spent so much time together, and you spend that much time together, you got to take breaks, you get to know them, you got to chat a little bit. So we weren't just, nose to the grindstone for 10 hours a day, but we did work really hard. And it was because we all had that same motivation that we want to get our homework done here so we can go and relax at home. I personally like that sort of separation between work and school, work and home, home and school, whatever you want to call it. But that worked really well for me. Not saying you have to do it that way. It was also important to be available when the TAs were available, though, because some classes, one in particular, physical chemistry, if you didn't have help from the TAs, I don't know how people passed that class. It was rough. It was really hard. Even with a full study group and help from the TAs, it was really rough. Test averages were low, homeworks were hard and took hours and hours. Hard course. And part of the reason it was so grueling is just the volume of assignments. Chemical engineering is very homework driven, and then midterms. That's really homeworks, midterms, and a final is guaranteed for pretty much every single class, and a lot of homeworks. We had a homework due between every single class, basically, unless there was a test. So if we were meeting 3 times a week, that means we had homework due Monday, Wednesday, and Friday every single week. I had a friend who put in all his assignments from a semester when we were in the big 3, the semester where we had the most things going on. And it was over 300 assignments between tests, quizzes, homeworks, and things like that. So pretty intense, and we had to stay really organized. We did have midterms, and they were usually a combination of short answer and long answer. So maybe we had a few like sort of fill in the blank type conceptual questions. If a reaction is exothermic, the heat goes out of the system, or something, fill in the blank. But mostly they were long answer, multi-part. So you'd have a test and it'd be 3 questions long, worth 100 points. Question 1 is worth 25 and has 4 parts, and question 2 is 50 points and has 6 parts, and question number 3 is 25 points and has 5 parts. So you go through, but lots of partial credit. And I was a teaching assistant, and we tried so hard to give people partial credit. We really gave you the benefit of the doubt. So TAs are on your side, professors are on your side. I had a wonderful experience at my school where I felt like the professors loved to teach, which I know isn't always the case everywhere. So I felt pretty lucky about that. On top of that, almost every chemical engineering class had some form of project, but they really varied. In one class, we had to make a 5-minute presentation at the end of the semester with a 4-person group, and you had a list of subjects. So you randomly assigned the group, you got the project, you each basically said, I have to talk for a minute, I'm going to talk about this part of the subject. Boom. It was pretty easy. It took a week and a half. Other things like our capstone, or even like our physical chemistry project, lasted 6 weeks, and you're working with a group while you're doing homework, while you're taking midterms, and it can be a little crazy at times. There were also lots of writing type assignments, usually associated with these projects, where you were doing lab reports or executive summaries of your analysis and things like that. So I'm actually going to post a link to my senior project on this video, if that's okay. I'd love to share that with everybody so I can check it out and see sort of what the culmination of my schooling was and see all the factors that went into it. Great, thanks for sharing. Before we move on from school real quick, would you mind sharing what your favorite class was and what kinds of electives you got to take as a chemical engineer, maybe focus classes or fun classes and things like that? Yeah, I can totally do that, definitely. So my favorite class was probably our senior capstone design project class. We called it plant design. And I liked it because, you spend an entire semester talking about thermodynamics or heat transfer, and a lot of it is just so theoretical or deep. And you're like, I can't believe people do this every day for their jobs. And some people do, but the majority of people don't. And so this class went through all the classes and they said, okay, we're going to spend 2 days talking about thermodynamics. Here's the stuff you actually have to know for your job. Oh, we're going to spend 3 days on heat transfer. That's all you really need to know. And so I like that because it boiled everything down to what you actually had to do for your job. It was good job prep. And on top of that, I got to work with my friends on a project for half the class. So that was really fun because it was more at your own pace, on your own timeline, less homework, things like that. So it was a really great class. As far as fun electives, there's not a lot of room in the chemical engineering degree plan for fun classes because they just require so many classes and they have to be in a specific order, one after the other. And so it was kind of hard. I did get to choose a couple of technical electives to do. So I took a biomedical engineering course, a computer programming course, and a petroleum engineering course. So that's about as fun as it got for me. But I did have a friend who he made sure to always put some sort of fun class in his schedule, and he liked the student activity classes. So he did jiu-jitsu and gymnastics and basketball and scuba diving and things like that he was able to work into his schedule as a half or 1 credit class. And that's how he liked to do it. But we didn't, just get to say, oh, that class sounds interesting. I want to learn about, pre-Victorian literature, because there just wasn't room in the degree plan. If you're trying to graduate in 4 or even 5 years, it would be pretty tough to do that with. Awesome. Thanks for sharing that. Let's kind of shift the focus for today. For the interview, we're going to go more career focused now. So if you could share kind of what typical jobs might be, what your experience was with what industries chemical engineers work in, and things like that. I'm sure they'd love to hear what your personal experience was with that. Yeah, so BYU had a really great mix of relationships with different companies, so you got to see that variety. So there is the typical oil and gas. When people think of chemical engineers, they think oil and gas. But they did also have relationships with semiconductor manufacturing companies, with consumer product companies like PepsiCo and P&G, aerospace companies in Utah like Orbital ATK, Northrop Grumman, defense companies, L3 Communications, medical device companies. We have RB and BD and Merit Medical here in Salt Lake. So a lot of opportunities there, a lot of breadth, and I was grateful that they had all these different avenues you could explore if you were looking for different opportunities. As far as chemical engineers, they can work for a company like that and be a chemical engineer for them, but contracting is also pretty common as a chemical engineer, whether it's a contractor who designs certain systems, or if you have chemical engineers who come and troubleshoot things. They do maintenance. You say, my plant's not running efficiently. Can you come in and do like an audit of our operations and see what we can do to be more efficient? Either way, being a contractor working at a small engineering firm is also a viable option. Also, a lot of field engineers, maybe where if you work at like remote sites, like oil field sites or things like that, then you have a home base, but you're going to be on the road a lot, going to all these different sites to implement projects or things like that. The most common job titles I saw were process engineer, production engineer, facilities engineer, basically all centered around there's a plant, we need you to work in it. So typically there's going to be an office building kind of next to the manufacturing floor, the manufacturing facility, or even inside the manufacturing facility. And so you have a cubicle at a desk and you spend a lot of time there, but you also go out into the field probably daily, if not multiple times a day, and go out there to troubleshoot issues, verify quality, talk to the operators about what improvements they'd like to see, and things like that. The schedule is very much so a kind of typical 9 to 5. I mean, normally it's a little shifted earlier, like 7 to 4 kind of thing, because most of the time the operators who run the plant work 12-hour shifts, like 6 to 6 or something like that, or 7 to 7. So you need to be there most of the hours that the day shift is there. So if they get on at 6, you need to be there between 7 and 8 once they've settled in, and then you need to be there till 3 or 4 or 5 before they start to wind down. Main responsibilities, like I said, are getting to know the process, improvement. If anything emergencies happen or process upsets happen, you're the point of contact where they say, well, what should we do to correct that? And there's loads of people to help you, people who are more experienced, your supervisors, your managers, the operators who have been there for 40 years. So you're not alone, but that's kind of your role, is to be the be-all, end-all answer for questions about your specific process, whatever it might be. Chemical engineers could also work like in a lab as a lab manager, but typically, as far as just running tests in a lab, being a lab analyst, that's more of the line of chemists or biochemists or biology majors that would be doing the chemistry in the lab itself. A chemical engineer would be more going to a lab to say, we need to run these tests to see if the process, if we want to raise the temperature on a process, lower the pressure, is the product still the same? So being a lab manager could be an option, but not necessarily common. As far as locations for chemical engineers that comes to career, a lot of it is just tied to where the resources are at. If you're in mining, you have to be where the mining ingredients are, or the resources are. So you're going to be like in the Mountain West, copper and gold a lot in the Mountain West. If you're going to be in oil and gas, you need to be either a place where you can get it from a pipeline or from a boat, or next to the oil field, and things like that. There are lots of cities you can live in because chemical engineers can work at manufacturing plants, and it's a lot easier to build a manufacturing plant kind of wherever. Like I said, we had medical devices, we had semiconductors, and things like that. So lots of manufacturing in Salt Lake. And you could find that to a certain extent in a lot of different cities. But the biggest concentration is going to be, along coastlines or where the natural resources are. I do feel like chemical engineers were in pretty high demand. Like I mentioned, me and my friends were able to find jobs pretty readily, despite COVID. I mean, I had a job offer pulled because of COVID, so then I had to go job hunting again. But within, I don't know, that was in March, probably about 2 months, I found another job. And that's pretty typical. And then that's with, minimal experience. Once you have a job, have experience, it's a lot easier to go out and do those interviews and things like that. As I'm sure people are familiar with, you got to have experience to get a job, to have experience to get a job. It's that cycle. But yeah, and then I guess I will talk about salary just really quick. Salary expectations for chemical engineers are really great. Average was about 65 when I graduated in 2020. That's kind of what I knew was the middle line. People who are going to go work for oil and gas, they can almost hit 100K out of college, or some of them might hit 100,000 out of college. That does come at a cost. When you work at one of those facilities, their work week tended to be a little longer. Maybe 45 hours a week was standard. They had to work nights maybe once a year, coming on 12-hour night shifts to support operations, and things like that. And they didn't get to make that time up. They didn't get paid overtime. And so, they get paid more partially because of industry, but also partially because of the work they have to do. And that's just something they live with. Other manufacturing, it's a little more 9 to 5, kind of where I work now in aerospace. I'm mostly there on day shift. I mostly work exactly 40 hours in a week. You get paid a little less, maybe the 70s, low 80s, high 60s, somewhere like that. And then I do have some people I knew who went and worked for a water wastewater utility contractor. And so again, as a contractor, a smaller company, they got paid a little less. Also, water wastewater public utilities don't get paid as much. So they're making about 55K a year. Across the board, great salaries, no complaints for anybody, but just sort of showing you that spectrum. Wow, thanks. Yeah, I think you answered all my questions. I mean, you should be giving this interview yourself. It seems like you know exactly what I'm talking about and exactly what I want to know. So the last thing I kind of want to get into, if we've got time, we've still got maybe 10 or 15 minutes left, is get into your work experience, project experience, whether from school or projects you did while you worked, maybe internships, and stuff like that. That way people know exactly what to expect with some specific examples, if that'd be all right. Yeah, that'd definitely be all right. I'd love to share that. So when I was in school, I did have 3 internships. So that I worked at an oil refinery twice and at an iodine plant once. So my first internship was at an oil refinery in Southeast Texas, and I was in the process safety management group, which is basically it's like a subset of OSHA that pertains to chemical manufacturing facilities. Um, and my main project while I was there is that they do what these are called HAZOP studies, hazards and operability studies. And basically, they take a unit that is either being designed or in operation, and they break it down into nodes, pieces. They say, well, here's the first reactor section, or here's the separation column, here's the steam header, whatever it might be. And they basically go through what are all the things that can go wrong. And they do this by methodically going through a list of upset conditions. So they have, things like more or less or no, and then you pair it with a variable like pressure, level, flow. So what happens if we have more pressure in our steam header? What happens if we have a low level in that tank, et cetera, et cetera. And then you say, this is what could happen. Is it a safety risk? Is it an environmental risk? Is it just a business risk? We're just going to lose a little efficiency, a little money. But you classify the risks, and then if they are a high enough risk, you have to prove that you have systems in place to counteract that, whether that's an operated procedure, whether it's an automatic safety check or safety shutdown or safety release or something. And you get certain credits or points for that and get it down to where you can say, my plant is safe because of these things. And that may sound super important. Wow, you learned about these processes and you're keeping it safe and making sure that it's all designed safely. Well, as an intern, my job was to make reports, print out the drawings, make summaries for my supervisor because he was manager for PSN, process safety, for the entire plant. So he was a really busy guy. So of my, I think it was a 16 or an 18-week internship, January to May, there were probably about 6 to 7 weeks where I spent every single day in a conference room for like 9 hours a day. So that was a little bit rough as an intern, but I will say it was invaluable experience because I spent 9 hours a day looking at drawings of the plant, what they call process and instrumentation diagrams, PNIDs. I learned how to read those really well. I also learned about sort of standard practices. If you have a vessel, how do you protect it from high pressure? Oh, well, you put a valve on it, and it has to be, this set point, this size before it will open. And so I kind of got exposed to a lot of different things, and also a lot of different units in the refinery. I learned about crude units. I learned about hydrotreaters that pull the sulfur out. I learned about I think a sour water stripper that also pulls sulfur out. I learned about all sorts of different processes, and so that was really cool. And I got to interact with engineers, operators, and an outside contractor who came and facilitated these HAZOP studies. As for the rest of my time there, I did go out in the plant a lot because PSN fell under the environmental health and safety umbrella. So I went out with the safety department and we would do audits where we'd walk around the unit and say, do we see any unsafe conditions? Do the contractors have their permits and are they filled out correctly? Are they staying out of the line of fire when they do work? Are the hoses all inspected and labeled? Things like that. So that got me comfortable walking around in a plant environment. While I was there, sort of typical stuff that you would wear was coveralls, these fire retardant coveralls. And so under that, I just wear like a t-shirt and basketball shorts. So they were actually kind of comfortable, kind of dorky looking, but kind of comfortable. And then I would, you had to have a hard hat, you had to have safety glasses, you had to have earplugs, you had gloves, you're climbing up and down ladders, up and down stairs. Everything's kind of dirty and grimy, but I loved it. It's kind of what converted me that I wanted to work in a big manufacturing facility that's noisy and dirty and big. The plant I worked at, actually, it's one of the largest in the US. It refines 330,000 barrels of crude a day. A barrel is 42 gallons. So that's like over a million, well over a million gallons a day. And at that rate, you could fill an Olympic-sized swimming pool in almost like about an hour. So that's a lot of water, or a lot of oil, sorry, going through the pipes. And I loved that about it. The experience was also super important because it led to my second internship, which was at the iodine plant. I got this because my brother-in-law's, my wife's brother, no, my wife's husband's brother worked at this iodine plant in northwest Oklahoma, about 2 hours from where I lived, and he needed a project done. His plant had no P&IDs. They'd been in operation 30 years and just no one had ever made them. So he said, "Can you come do that for me?" It was an 11-week internship. It was super flexible because he knew me and I was close to home. I got LASIK that summer, which was really nice. So it was a great experience, and it was kind of showed that once you have experience, you can leverage it for your future experience. My last internship was in process engineering, like back at the refinery. And this is, like I said earlier, a very typical engineering job. I had a mentor, and he was over the docks, the tank farms, the water treatment plant, and the wastewater treatment unit. So a lot of sort of utilities type things. But I got to do like a hydraulic analysis. So like that's fluid pressure. How much, if we want to load faster to the boats at the docks from the tank farm, how big of a pump do we need? How big of a pipe? How much should we increase the diameter of the pipe? And things like that. I also kind of learned and got my toes wet in process controls, which is what I do now. I was looking at units and it was on an old isolated system. We wanted to put it on the plant-wide control system. And so it was my job to look through all the P&IDs, which again, I was very familiar with, and say, here's the important process variables, here's what they're called, here's where they are in the field. Let's migrate those data collection points into the new system. Then I had to make graphics that we could use to monitor what was going on in the plant and sort of learn that process inside and out, specifically the water treatment plant. Career-wise, internships can be pretty important for chemical engineers. I had a couple friends who graduated without internships and they got a job just fine. But if you can get at least one, you'll really be a lot better set off because you have just good experience to share in a job interview for full-time. Or your internships can turn into full-time. I did have an offer to work for Valero, but for some personal family reasons, we decided not to take that route. And we stuck around here in Utah. So now I work at Northrop Grumman. I work at a rocket production facility, which is pretty dang cool. Because aerospace was kind of my first love or first dream. I got a poster from the book fair in like the second grade that had a supersonic jet on it, showing it breaking the sound barrier, and I just loved aerospace ever since. So I also did get into my dream niche, and that's something I guess it's an important message to share from people watching this, is that your major and your job rarely line up one-to-one, because if you have a job here, there might be 5 different majors that can all lead into them, or this one major can lead into 5 different jobs. And so mine is, I'm in process controls, which is basically automation of manufacturing processes. And you could do that as a chemical engineer, a mechanical engineer, an electrical engineer, or even just if you're an operator who worked in the plant for a really long time and has that experience, you can learn the skills and become a process control engineer. So keep in mind that your degree can be very broad, but I ended up in sort of this dream niche of my major, and I'm super excited about that, and I'm excited to be here. I get to use some of my chemical knowledge for processes, but I help automate and support utilities. Without talking your ear off too many details, the way that you make a rocket motor, and the part that I'm with is that you take the case and you stick it in a pit vertically, and you just pour the propellant into the motor case. And maybe you have a mold in there, so it will be the propellant be shaped the right way. And you have to mix all this propellant. We mix it 1,800 gallons at a time, which is like 20 or 30,000 pounds at a time, in these massive mixing bowls. And then we let it drip out there, and then you have to keep it hot for it to cure, kind of like a ceramic, pot or something. It has to be hot for it to solidify and cure. And then you have to make sure that it's the right quality. You have to take out the molds, and so it's a whole production. And I only see a little piece of it, but I'm super excited about it. And it's a great place to work, and I'm learning a lot. Yeah, thanks for sharing. Like I said, that's a great experience. You have a kind of diverse experience, which is kind of nice, and hopefully, will help people understand what you do for a job and what career options are available. One last question for you, maybe. Are there any regrets you have about chemical engineering that you'd like to share, or any cautions for people? Yeah, definitely. My one regret is that I don't get to do the physical work myself. Having done robotics and projects with my dad growing up, I like being hands-on, and I get to go out in the field. I get to look at them, do troubleshooting. But as far as, hey, we need to swap out that input-output card, or we need to install this, new control valve or whatever. That's all the electricians, the mechanics. It's all unionized and stuff, and so we aren't allowed to touch it. And so I do kind of miss that. But again, that's the kind of thing where you can have it as a hobby at home, doing hand and home projects. So I scratch that itch elsewhere. Um, Other than that, I don't really have any complaints or regrets about chemical engineering. I think it's a fantastic opportunity. I would love for more people to do chemical engineering because I think it's just so awesome. But it is hard. It's a lot of time, a lot of dedication. You have to understand math and chemistry and physics and be able to see broad and narrow. So it's a lot, but I think it's well worth it if you can struggle through it and make it through that. Well, thank you for being on the show. Thank you for sharing all your experience. Again, this has been our first episode of Major Discussions here on the College Guide. This was Skyler Cornaby. Find him on LinkedIn. Go connect with him. If you have questions, he'd be willing to answer them, I would assume, because he seems like a really awesome guy. But yeah, thanks, and thanks for tuning into this episode. All right, if you're watching this and you're still watching, one of two things is probably true. Either A, you're interested in chemical engineering, at which point you can jump to a different playlist. You can jump over here and maybe go watch the College 101 playlist, or where you can learn about all my best tips for college, or you can check out this video that is about all the numbers of chemical engineering, average salary, where you might have to live, demographics of chemical engineers, and give that check that out and give it a try. If you are still watching it, you're in that second group, and that means that I have asked you to come and be on the College Guide on Major Discussions as a guest. Thank you for bearing with me through this cheesy interview. Hopefully you just kind of skimmed it. But if you would like to be part of this, come and support, come and help people learn about different majors, let me know. Please respond to whatever message I sent you. I'm super excited to share with people about all these different college majors, and I just don't have the knowledge, so I'm grateful for your help and the opportunity to work with you. Thanks again for watching this episode of Major Discussions here on the College Guide. We'll see you next time.